fine, but it is important, okay? So stick right with me. I think it'll take like 45 minutes. So hopefully by the time we're done, you guys will have some time to work on your homework. For those of you who have corrections on your desk, you can work on those, okay? So you guys, we already talked about end behavior a little bit when we were adjusting those graphs. Remember that was on the test. So this is going to kind of hopefully help you with that concept as well. Okay, so grab your pencil, and right here, let's graph the line y equals x. It just looks something like that. Okay. Y equals x to the third, we've graphed that before. You guys know that that is a cubic. Looks like that. Does anybody know how y equals x to the fifth compares to y equals x to the third? Do you know? It's very much the same. It's just what? Just gets more narrow, gets steeper faster, right? So it's just a little bit closer to that y-axis, and it looks like that. Okay? Now what I want you to notice, you guys, is these exponents are all odds, okay? So you've got a 1 and a 3 and a 5, so they're all odd. So look what's happening on the left side of the graph, okay? This left side right here goes down. This left side goes down. And this left side goes down, okay? Now, people get confused, so I want you to draw a box right here, okay? And then I want you to put a dot right here in the left upper corner, and then in the left lower corner. So the left arrow has two options. Point it left up or left down. So if you look at those three, they're all down. So my left arrow is going to point to the lower left corner of a box. It is not this. It is not straight down. It's to the corner of the box. So you've got to point that thing out. Okay? Okay, everybody look at the right side. Right up, right up, right up. Now I want you to look at the box again. Here's a dot right here. Here's a dot right here. So your right arrow either points right up or right down. So mine are all pointing up. So it goes right up like that. The left arrow is on the left, the right arrow is on the right, and that is called end behavior. We're going to talk about that a lot. That's the end behavior of the graph. Okay? Okay, let's do the next one. Y equals x to the second. Okay, draw that, and you guys know that that's a parabola. Okay? Y equals x to the fourth. What's that?
Is it wider?
It's not wider, it's actually more narrow. It comes up faster. Okay? So it's going to look like this. How about to the sixth, you guys? Even more narrow. Yep, exactly right. Does it go completely vertical? Tell me that. No. It goes really, really steep, but not vertical. Okay. Notice the exponents, guys. 2, 4, and 6. They're even. Okay. Now look at this, guys. Left up, left up, left up. Take your pencil and point it to the left upper corner of a box. Looks like that. The right side goes right up, right up, right up. So take your pencil, put it on the right side of the arrow that's there already, and point it to the right upper corner of a box, like that. That's called the end behavior, okay? Here's what this means, okay? Everybody look forward. I think people don't really understand end behavior, and that creates a problem, so I want you to look. Look at this end behavior right now, right here. What that means is as x gets really big, my graph's going up like that. As x gets really small, my graph's going up like that. What happens in the middle? Not quite sure, but I know for sure as it gets small, it goes up. As it gets big, it goes up. Who says I understand? Raise your hand. It's called the end of the graph, the right and the left, okay? All right. So let's fill in this little chart right here, okay? Even and odd coefficients, okay? So if you have an even x degree, like y equals x to the second, and a positive leading coefficient, the leading coefficient is the number in front of that x to the second, okay? So if it's a positive, then you know that this is a parabola that opens up like that. So my left arrow would be left up. My right arrow would be right up. Okay, make sure you fill that in. What if it was a negative x to the second? That would make that guy open down, right? So with the left arrow, everybody tell me, go left up or left down? Left down. And then the right arrow would go right up or right down? Right down. Okay? Now let's look at an odd. So y equals x to the third. So that is a cubic. And there's no reflection on that cubic. So you tell me left arrow, left up or left down? Left down. And then right arrow, right up or right down? Right up. Okay? Now let's put a negative in front of it. Answer this question. If the negative is right there, sitting out in front, does that mean a reflection across the x or does it mean a reflection across the y? Alphabetize x and y. What comes first, x or y? X and then y. So if the negative comes at the first, it's x. If the negative does not come first, that would be does not come first, it's y. So I'm going to ask you again, is that a reflection across the x or a reflection across the y? It's x, yes. Okay, reflect that thing across the x-axis and it's going to turn it like that. Okay, left arrow is left up, right arrow is right down. Okay, now I want you to look at this. Just kind of kick back for a second and look. Is that right there an acceptable end behavior? No. It's not, because the left arrow is pointing to the left and it's supposed to, pardon me, it's pointing to the right and it's supposed to be pointing to the left. The right arrow is pointing to the left and it's supposed to be pointing to the right. Let me show you what this means. People are like, well, I know the left is up, so why does it matter where it's pointing? Watch. These arrows means it continues, then I have to connect to make a graph. So that person is saying that the graph looks like that, right? Does it make sense? Okay. Okay, one more thing I want to say about end behavior, okay? I want you to fill this in somewhere. Do you guys have like a big blank area like I do? I don't know what's up with that thing. On what we've already just had. Look right here. Maybe go to the bottom of page 30 and fill this in. It's up to you, wherever you want to fill this in, okay? Okay, so left arrow, and then a line, and right arrow. People get all freaked out about the arrows, okay? It's not tough. Draw a box. Dot on left up, dot on left down. So you have two options for your left arrow. Only two options. One of them is left up. The other one is left down. Those are the only two options. Okay? The right arrow also has two options. See if you can draw the two options for the right arrow. I want to see if you understand. Here are the only two options. Look, right up or right down. Who says I knew that? I drew that all by myself. Yay. Okay, let's keep going. Example 1, find the end behavior. Okay, so what I want you to do on this is I want you to group those together and group those together. They're not the same. Guys, look at question A and compare it to question D. So question A is all multiplied out. Okay, so let's write down multiplied out. Question D, if you look at it, it's not multiplied out. It's actually factored. So you've factored that thing all up. So that's the difference, okay? A, B, and C are so easy. Look what you do. Okay, everybody watch. You look at the biggest exponent, which is a 3. You disregard the 1 and the negative 4x a second, because those don't dominate the end behavior. The end behavior is dominated by the biggest exponent, which is a 3. Okay, now watch. 3 is odd. Odd means cubic, so it's going to look like that. But we have a negative in front, which means to reflect. So the graph is actually going to look like that. Okay, So everybody in the room tell me, is it left up or is it left down? Talk to me. Left up. So that's your option of the two arrows, right? Right arrow, right up or right down? Talk to me, everybody. Right down. There's your answer. That's your end behavior. Okay, let's do the next one. The negative 7x affects the graph, but it doesn't dominate it. The dominating term is here. The exponent is 4. That's even. That means parabola. Does my parabola have a reflection? Talk to me about that. No. How do you know that? There's no negative, right? So the left arrow goes left up, the right arrow goes right up, and I'm done. Okay, who says gotcha? Let's see. Okay, great. Next one. Get rid of it, dominates. 4 means parabola. Negative means down. So your graph is going to look like this. So your end behavior is left down. Your right is right down. There's your end behavior. Easy. Okay. Write a little note out over here to the side and say, look at biggest exponent. Very, very simple. Okay. These next 3 are a little bit tougher, but really not that bad. Okay. Look right here and watch. Okay. Out of x and negative 2, what dominates? X. Out of x and 1, what dominates? X. Out of x and negative 5, what dominates? X. I don't have to multiply that whole thing out. That would take me like 4 minutes, and I'd probably be wrong when I was done because there's so many places that you can make a mistake. But if I did multiply it out, then I would have an x to the what as my biggest exponent? Third, because you go 1 plus 1 plus 1. So it's an x to the third. Would there be a negative sitting out in front of the x to the third, you guys? No. So it's just a regular cubic. So my left arrow is left down, my right arrow is right up, and that's my end behavior. Okay? All right, this one right here. The x dominates, not the 3. The x dominates, not the 1. Now you have to be careful because there's a negative sitting there. So we have a negative, and we have an x to the third, and we have an x to the second. You guys, does that give me a negative x to the 5th or a negative x to the 6th? What's the rule? You add them. So it is 5. Yes. Okay. So everybody write x up above, write x to the a multiplied by x to the b is x to the a plus b. So if you multiply, you add the exponent. So I have a 5. Okay. 5 is odd. Odd means cubic. So it would look like that. But I have a negative. So it reflects my cubic the other way. So my left arrow is left up, my right arrow is right down, and I'm done. Who says I'm good? This is easy. Okay, yay. Yay, yay, yay. Here we go. Get rid of the 3, get rid of the negative 2, get rid of the 1. They don't dominate. The first x is to the first, the second x is to the second, and the third x is to the third. Then I add those together and I get 3, 4, 5, 6. 6 is even. Even means parabola. I don't have a negative in front, so my parabola opens up. So my arrows are left up, right up, and I'm done. Okay? Who says, I'm totally good? Give me some feedback. Okay, great. Write a note to yourself that says, add exponents. Okay, you have to differentiate between the first ones and the second ones because you're going to get it both ways. You're going to see sometimes the first ones and sometimes the second ones. Okay, y-intercepts. You could only have one y-intercept if it's a function. And I want you to remember that it is 0, some number. That's how you y-intercepts. X-intercepts are written as something, 0. Okay? I want to make one comment. Just add this right underneath this. Everybody write y equals x to the 4th minus 3x to the 3rd plus 1. Okay? If they ask you the maximum number of x-intercepts? Okay, the answer is the biggest exponent, which is a 4. Okay, have I ever seen them ask that? No, but we better cover it. Okay, question 2a. Find the x-intercepts and y-intercepts. So I'm very picky with you guys when you do these problems. I need you to know that I expect you to write down x-intercept and I expect you to write down y-intercept. Okay, and then I'm going to set myself up. To find the x-intercept, I'm going to let y be 0. To find the y-intercept, I'm going to let x be 0. So I've set myself up. I haven't even looked at the equation yet. Okay, which one's easier to find right now, x-intercept or y-intercept? Why? If you let the x be a 0, this is a 0, this is a 0, this is a 0, what's this? 0. Okay, now, if 0, 0 is a y-intercept, then talk to me. It's also an x-intercept because 0, 0 is on both the x and the y-axis. Does that mean that I'm done? No, because you might have more, which ones? The y's or the x's? More x's, okay? So let's look and see. To find the to find the x-intercept, you let y be 0. So everybody go x to the third minus x to the second minus 2x equals 0. Everybody look at that. Can I use the quadratic formula right now to solve that? No. Why not? Because it's a cubed. Quadratic formula is when you have a parabola, when you have a quadratic, okay? Can't do that. What do? Take out an x. Everybody has an x, so let's take one out. Then I'm left with x to the second minus x minus 2. Please don't forget your equals 0. Look at how I've written that line. That is how you have to write it. You can't just write pieces of it. You write the whole thing, okay? Tell me with one word what to do now. Factor is exactly right. So the x a second goes to an x and an x. The 2 goes to a 2 and a 1. Signs are different. Biggest is the negative. So the 2 is the negative and the 1 is a positive. Okay, everybody listen. Just freeze right here for 2 seconds. I have a piece of paper in my hand right here, all crinkled up, and you can't see it. And I have another piece of paper with a number on it, crinkled up and in my hand. You have no idea what my numbers are. But I tell you this, if I take this number and I multiply it by this number, I get a 0. What do you know? One of them's a 0. Could they both be 0? Yes. They could, because 0 times 0 is 0. But I know one of them has to be a 0. Okay, that's what we've got right here. Okay, so everybody look. How many numbers do I have? I have 3 of them. I have an x, I have an x plus 1, and I have an x minus 2. So I have to set each of those equal to 0. So set the x equal to 0, I get x equals 0. Set the x plus 1 equal to 0, I get a negative 1. Set x minus 2 equal to 0, and I get a 2. But you can't write it like that, because they're intercepts. So you write it as 0, 0, negative 1, 0, 2, 0, and I'm done. Okay? So, oops, didn't mean to scribble like that. So, this is how I'll write my answers, like that. Okay? All right, let's go to question B. Okay, I want you to be very clear to me. Look, x-intercept, y-intercept. To find the x-intercept, let y be 0. To find the y-intercept, let x be a 0. The y-intercept isn't so easy right now. So I'm going to do this, guys. Everybody go, f of 0 is equal to 0 plus 1 squared times 0 minus 1 squared. 0 plus 1 is a 1. 1 squared is 1. 0 minus 1 is a negative 1. And negative 1 squared is 1. So those are both 1s. Multiply them together, I get a 1. All I did is put a 0 in for x. Over here, it's easier. I'm just going to go x plus 1 squared times x minus 1 squared is equal to 0. They've already factored it for me, so it's so much easier. Set this equal to 0, I get x equals negative 1. Set that equal to 0, I get a positive 1. Now, when you're writing intercepts, don't do plus or minus. You'll know why later. Don't do plus or minus. So one x-intercept is negative 1, 0. The next intercept is 1, 0. Highlight your answers, and you're done. Some people just list them. They just go -1, 0, 1, 0, 0, 1, and I take points off. Why? Because they didn't tell me which one was which. I need you to tell me that you know which one's which. Okay? All right, question C. X-intercept, Y-intercept. To find the x-intercept, let y be 0. To find the y-intercept, let x be 0. Now, in my opinion, the x-intercept is easier. Look, I could literally just do that. Set the y equal to 0. What do I get? -3, 0, 2, 0, and -1, 0. Now let's do the y-intercept. So everybody go, y equals 0 plus 3 times 0 minus 2 squared times 0 plus 1 to the third. All I'm doing is putting zeros in for x's. So I get y equals 0 plus 3 is a 3, 0 minus 2 is a -2, a -2 to the second is a 4, 0 plus 1 is a 1, 1 to the third is 1. Multiply those together, I get a 12. My answer is 0, 12, and I'm done. Who says easy? Get it? I'm good. Give me feedback how you're feeling. Okay, good. All right, now, bouncing and crossing. I want you to draw an XY axis above where it says bounce and an XY axis above where it says cross. Then I want everybody to go out to a 2. Why did I choose 2? It was a random choice. Just put a dot right there. Okay? I want to make sure you know what bounce looks like. Let's say we're below the x-axis. Okay, so if I'm below the x-axis and I'm traveling from the left to the right, and this is a bounce, I'm going to hit it and I'm going to bounce down. That's what a bounce looks like. Okay, come over here, do the same thing. We're down below, but this time we're going to cross, so it's going to go like that. It's going to cross through to the other side. Okay, I'm not trying to scare you. I'm just trying to give you a heads up. There's a lesson coming up in about, I don't know, 2 or 3 lessons, and it's not easy. And my students last semester, they struggled more than my students have struggled in the past. You know what it is? Horizontal asymptote, vertical asymptote, hole, bouncing, crossing. See, now you're moaning, huh? Who says, yeah, I remember that. I remember. Yeah, we're doing it. And it's going to be on your midterm. But you're going to be awesome at it. You're going to be awesome at it, so don't worry. Okay, so if the exponent is even, it bounces. If the exponent is odd, it crosses. This is on x-intercepts only. Guys, look. Would a y-intercept ever do this? Look. I'm drawing my graph, I come over, I hit the y-intercept, and I bounce. Would it do that? No, it's not a function anymore. Good. Okay, so let's come over here. See this 0, go back to question A. See this 0, 0? It came from this x right here. What's the exponent on that x? 1. 1 is odd. Odd means cross. I want you to put a C right there. This -1 right here came from the x plus 1. The outside exponent is a 1. 1 means odd. Odd means cross. This x equals 2 came from the x minus 2. Exponent's 1. 1 is odd. Odd means cross. So they would all cross through. Okay, let's look at the next one. This -1 came from here. The exponent's even. That's going to bounce. So put a B right there. This x equals 1 came from here. Exponent's even, that guy's going to bounce. Put a B. These are only x-intercepts. Okay, come back to these ones. This -3 came from the x plus 3. Exponent's 1, cross. X equals 2 came from here. Exponent's even, that means bounce. -1 came from here. Exponent's odd. Odd means cross. Who says I'm with you? Raise your hand. Let me see how we're doing. Okay, great. Okay. Question 3, and then we're going to really do what the task of this lesson is, okay? Find a 4th degree polynomial that has these zeros. I want you to take your highlighter and highlight the word zeros. There are about 4 other words that also mean zeros. Somebody tell me one of them. Just shout it out. X-intercepts. Yep, write this down. X-intercept. Give me another one. Solutions. Yep. Give me another one. Roots. And I think there's another one. Maybe not. Those are good for now. They all mean the same thing. Okay? So you want solutions, 3 solutions right there. Okay? So everybody go y equals. I want it to be an equation. So the x equals 2 means you have an x minus 2. Set it equals 0, you get your 2. X equals negative 1 gives me x plus 1. Set it equal to 0, and you get a negative 1. The 0 gives me a what? An x. And that's so weird to put it at the end, right? It's awkward. So I've left a little spot, and I'm going to put it right there at the beginning. Okay? That's not right. That answer's wrong. What's wrong with it? You only have 3 degrees, an exponent of 3, and it's supposed to be 4. Okay? Well, they didn't tell me which one's bounced and which one crossed, so I can just randomly choose one of those 3 factors and add an exponent to it. So I'm just going to make that a squared, and now we're good. Okay? And you don't have to multiply it out. We're just going to leave that. Okay? Question B. This one's a 5th degree. I don't have any zeros, so I'm not going to have an x sitting out in front. Okay? The x equals 2 gives you an x minus 2. X equals negative 2 means x plus 2. X equals 3 means x minus 3. It's not the answer. What's wrong? I need to add how many more? Not 3 more, because I have 3 and I need 5, so I'm missing, tell me, 2. So if this guy was a 1, I could make him a 3. Or I could make a couple of them 2s. It doesn't matter. Because it didn't tell me what bounced, what crossed, so that's totally fine. Okay? All right. Here we go. Yes, honey?
Would there ever be a situation where it does tell you what bounced?
Could. I don't think you would ever see it, but yes, they absolutely could. Okay? Okay, here we go. You're going to graph that function. Okay? Nice and slowly. Find all the intercepts. Okay, so everybody say x-intercept, y-intercept. To find the x-intercept, let y be 0. To find the y-intercept, let x be a 0. So let's let y be a 0. So everybody go x times x minus 2 times x plus 2 gives me a 0. I can tell I'm going to have 3 x-intercepts. One here, one here, one here. So I get x equals 0, 2, and negative 2. So it's going to be 0, 0, 2, 0, and negative 2, 0. You guys, the x-intercepts are the ones where we have to decide bouncing or crossing. So let's do that right now because we have to graph it. All of the exponents are 1s, so they all cross. So I'm going to put a C right there. Okay, and I think on the quiz, because I write your next quiz, I think I put, tell me if it bounces or crosses. If I don't, I'm going to add that. I need to. Okay, you guys, look. You have an x-intercept of 0, 0, so I know this is going to be 0, 0. I also know I can't have more than one y-intercept or I don't have a function, so I can just write it down and I'm done. Okay. Okay, question B. I want you to listen very carefully. I want you to skip this question. Okay, skip it. We're going to come back. Question C, tell me the end behavior. Okay, look at the equation. Okay, so you have f of x equals x times x minus 2 times x plus 2. So this is going to be an x to the what if I multiplied it all out? Third. I want everybody to write f of x equals x to the third. Okay? The reason I want you to do that is this. It says state the power function. This is the power function. Okay? Maybe draw an arrow right there. If you don't write f of x equals x to the third, you're going to lose points because you didn't list the power button function, okay? But what we're really needing on this problem is the end behavior, the arrows, okay? So it's a cubic, so it's going to look like this, okay? No reflection, there's no negative, so the end behavior is left down and right up. It's going to look like that. Yes, honey? You don't have to. You can do it just like that. Yeah. Okay. Now we're going to graph it. Here we go. Everybody put a dot right here at 0, 0, and I want you to put a C right there. Put a dot at 2, 0, and put a C, and put a dot at -2, 0, and put a C. Now I want you to watch closely. Okay? This is so closely related to that other question that was on the test where you have to take the points and then y becomes and x becomes and all that business. So watch right here. The left part of my graph I know is down. Okay, so everybody grab your pencil and point that guy down. He has to be down on the left. Okay, now just watch me for 2 seconds. Watch. Cross through. Peek up in the center of those 2 dots, like right here. Hit there. Cross through, peek down, cross up. Now freeze before you write it. Do you see how the right ended up? And my end behavior right here told me that the right was supposed to end up right here. Don't know what that is, but that right is up. So I'm feeling really good. Okay? Okay, go ahead and draw it in. It moved the box around the arrows. I don't really know how that worked, but I can see what happened. Okay, we're not done with the question because we didn't do part B. Okay, here's what part B is asking you. People mess up on this part. I don't want that to be you, so I want you to listen, okay? X and Y. X, Y axis, table of values. Guys, look at my graph. Do you see how I have 3 x-intercepts? I'm going to have 4 regions. Point, 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 point. I have to have 4 ordered pairs. So Weber State wants you to prove where the graph is during different regions. So you don't have to do this to your paper, but look at mine. The x-axis is split into that green region, this yellow region, this pink region, and this purple region. So what they want you to do is to choose a random point out of every region and test the sign of that number, okay? So in the green region, I'm going to come over here and I'm going to choose a -3. In the yellow region, let's all just do a -1. Make it easy on yourself. In the pink region, we're going to choose a 1. And in the purple region, we're going to choose a 3. Okay? Now, grab your calculator. See that -3? We're going to store it in our calculator. Okay, so do this with me. Everybody have your calculator. Go -3, store, enter. The store is on the left-hand side, second button up. Now what I'm going to do, I'm going to show you something I haven't shown you on this calculator. See this equation right here? We're going to put that in. Okay, so everybody go membar, enter, parenthesis. Membar, enter, -2, close it. Parenthesis, membar, enter, +2, close it, enter, and I got a -15. So all you have to do is fill in the -15, and you got it. What's wrong? Do it again? Do it again? Okay, no problem. And I felt like I was going so slowly. I think it's just so like innate for me. You know what I mean? I've done it for so long. Okay, here we go. Start all over. Erase. Okay, here we go. -3. All I had to say was -3 and then it worked for you, huh? Okay. -3, store, enter. Membar, enter. Parenthesis. Membar, enter, -2, close it. Parenthesis, membar, enter, +2, close it, enter, -15. The next one is so easy. Look what you do for the next one. Listen right here, okay? See the next one? Guys, listen, you're going to get confused. See the next one's a -1. Do these buttons. -1, store, enter. Then I want you to go up, up. You're back on top of the equation again. Hit enter, and you get a 3. So all you have to do to access that is go up, up. Okay, let's do the next one. 1, store, enter, up, up, enter, -3. Next one, 3, store, enter, up, up, enter, 15, and I'm done. This right here, in my opinion, is silly and unnecessary. Because I already knew how to graph it. I just had to go back up and fill it in. I want to explain to you what this means so you understand. It means if x is a -3, y is a -15, so you're clear down here, so I know I'm below the x-axis. If x is a -1, I have a positive. If it's a +1, I have a negative. If it's a +3, I have a positive. It just shows you where to do the graph. Well, I already knew it because we do the bouncing crossing thing, right? So I already knew. Okay? Question?
Are we going to do that in our tests?
Yes. Well, they used to always make you. Now, not so sure. So I don't know is the answer to the question. So we're going to do it just in case. And it's not like it's tough. You know what I mean? Okay, here we go. Question number 6. A little bit faster. Okay? Find all the intercepts. So I want everybody to write down x-intercept and then y-intercept. To find the x-intercept, let y be 0. To find the y-intercept, let x be a 0. You guys, I'm not even going to make you show work on the x-intercept. Because you can just do this in your head. Look, set it equal to 0. The +1 gives me a -1. The -1 gives me a +1. So I have x-intercepts of -1 and +1. They're both even, so they both bounce. So we're going to put a B right there. Okay? To find the y-intercept, we're going to let x be a 0. Okay, so everybody go f of 0 is equal to 0 plus 1 squared times 0 minus 1 squared. Tell me what that's equal to. What is it? 0 plus 1 is 1. 1 squared is 1. 0 minus 1 is a -1. -1 squared is 1. It's not true because you're multiplying. 1 times 1 is 1. Okay? Done. Question B, skip it. It's silly. We'll do it at the end when we're done. Okay, give me the power function. Okay, so if you look at it, everybody go f of x equals x to the, talk to me. Fourth is correct. Okay, because 2 plus 2 on my exponents is 4. So I know this is a parabola that opens up. End behavior is the answer, and that is left up and right up. Please don't make those lines straight up and straight down because a graph doesn't go straight up and straight down. It goes like this. Okay? All right, let's graph it. -1, 0 and +1, 0. And the y-intercept is 0, 1. So I'm going to go like this. I'm going to put a dot right there. And I'm going to label it 0, 1. Sometimes Weber State asks you to label things. So you have to read carefully. Okay? You guys, I know this is a parabola that opens up, up, up. Okay, so look. The left side is here. And it's supposed to be up. So I know the left side of my graph goes up like that. Okay? This is going to bounce. This is going to bounce. So watch. Come down, hit it, bounce. Go up there, hit that, bounce. Head up. I was supposed to end up. I'm feeling pretty confident. I think I did that right. Okay? Who says I understand? Raise your hand. I feel good about this. Yay. I do think this will be on your midterm, just so you know. Okay? Okay, table of values. People mess up on this. You have 2 x-intercepts. If you have 2 x-intercepts, how many regions do I have on my graph? Tell me. 1 more than that, right? So 3. So here, and here, and here. Choose a value in the green. You guys just be easy on yourself. Just choose the next one, -2. In the center, 0. On the right, 2. You can choose whatever you want, but why would you choose something crazy, right? Okay, we already know from the y-intercept that if x is 0, y is 1, so I'm going to fill that in. Okay, let's do the -2. Grab your calculator. -2, store, enter. Put the equation in your calculator. So go parenthesis, membar, enter, +1, close it, x squared. Parenthesis, membar, enter, -1, close it, x squared, hit enter, and I get a 9. So fill in the 9. The next one's easy. It's like 4 buttons and I'm done. 2, store, enter. Up, up, enter. There's my number, 9. I'm done. That's it. Yay. Okay. Okay, question 7, and then we're done. Yeah. This is not easy, or not hard. See how smart you are? You understand all this stuff. Okay. And it's Friday, so everybody's happy. Okay, x-intercept, y-intercept. To find the x-intercept, let y be 0. To find the y-intercept, let x be 0. Imagine setting that equation equal to 0. What are your intercepts? -1, 0, 2, 0, and -3, 0. The x plus 1 has an exponent of 2, so that means it's going to bounce. The x minus 2 has an exponent of 3, that means the 2, 0 crosses. The x plus 3 has an exponent of 1, that means that crosses. Let's find the y-intercept. So everybody go, f of 0 is equal to 0 plus 1 squared, 0 minus 2 to the third, 0 plus 3. 0 plus 1 is a 1, 1 to the second is a 1. 0 minus 2 is a -2, -2 to the third is a -8. 0 plus 3 is a 3, you get a -24. You could also just put that in your calculator, whatever you want. Okay? So there you go. What are we going to do to part B right here? Skip it. Okay? End behavior. First of all, write the power function. F of x equals x to the, what's it going to be? It is 6. You add 2 plus 3 plus 1. End behavior, I know this is a parabola that opens up, so it's left up and right up. Okay? Looks like that. Here we go. Say it again. Oh. That is so important. Yay for you. Was that on the other ones? Yes. It was. Yes. Okay, I just skimmed right over it. Go all the way back to example 3. This was all over the midterm. And I just skipped it, and you just saved everybody. Yay. Okay. It's easy. It's easy, but we have to know how to do it. The maximum number of turning points, easy. You take the biggest exponent and subtract 1. Let's write that down. Biggest exponent minus 1. That's your answer. This is what a turning point is. Just look right here for a second. I'm going along, I'm going up, and then I turn. That's a turning point. Then I'm down and I turn. And then I'm up and I turn. So that graph has 3 turning points. One there, one there, one there. Okay, let's go back over to B. Pretend like it says, oh, it does. C. What's the maximum number of turning points? So we're going to go max turning points is, what's the answer? 2. Biggest exponent is 3. 3 minus 1 is a 2. It's very easy, but I'm sure it will be on your midterm. The next one. Maximum number of turning points. You tell me this one. It's, talk to me, you're scaring me. 3. Yeah, biggest exponent's a 4. Subtract 1, you get a 3. Okay, let's come back to the one we're doing. And let's go maximum number of turning points. You tell me. 5. You just have to remember it, right? It's easy. You just remember it. Okay, negative 1 comma 0, put a B. 2 comma 0, put a C. Negative 3 comma 0, put a C. Now, the y-intercept is 0, negative 24. That's crazy because it doesn't go down that low, right? Just put a dot and label it 0, negative 24. You graph it. Go ahead. Okay, I'm going to do it. Here's how you figure out how to do it, guys. It's that end behavior right there. Okay, everybody look. The left has got to be up. So I'm going to make my left up like that. Okay, watch and let's see if you got it. Come down, cross through, hit that, bounce, come back down, hit that y-intercept. Should I head up right now? Probably not, because the middle's like maybe here. So my guess is it's probably going to go a little lower. Come back up, hit it, cross through, up high, there it is. Okay, I have 3 x-intercepts. How many points do I have to have on my table of values? 4. I'm going to do a sideways table because I'm out of room. The left region, negative 4. The next region, negative 2. The next region, 1. Look what people do. The last region, negative 5. Is that okay? I didn't test the region on the right, and I test the region on the left, finish. So I got the left, okay, look right here. The negative 4 does on my left. The negative 2 does that one. The 1 does that one. And then the negative 5 does what? Come on. The one on the left again, right? I don't have to test that one again. So people test a region twice, and then they omit a region. So be careful, okay? So this is supposed to be what over here, everybody? Like a 3 would be the easiest, right? Okay, grab your calculator. Negative 4, store, enter. Parenthesis, membar, enter, plus 1, close it, x squared. Parenthesis, membar, enter, minus 2, close it. Now, how do I raise something to the third? Because we haven't done that. There's a button that looks like that. It's called the caret button. It's right here. Okay, it's right there. Hit that button. And then put in 3. And then go parenthesis, membar, enter, plus 3, close it, enter, and I got 1,944. Okay, negative 2, store, enter, up, up, enter, negative 64. 1, store, enter, up, up, enter, negative 16. 3, store, enter, up, up, enter, 96. And I just jumped through that hoop. Jump through a hoop means I just did something I don't think I really need to, but to get the points, I got to do it. Okay? Okay, we're done. Yay. Yay, yay.